Okay, and then what we're looking at quality assurance. So it's an interim phase. Okay, it's like a part that we are trying. It's like a bridge. Okay, from QP to QC. You see, so a lot of time people talk about QA, QC, QA, QC. Actually, what is actually QA? And then some people say, oh, QA is ISO. Oh, I'm so sorry. It's actually not ISO. So quality assurance is actually an interim. It's like a bridge part of the TQM system. So meaning that with the project, it's like a middle part of it. So in project planning, you're planning to monitor, you're planning to check. And then in QC, you're actually checking and doing rectification work and helping things to get better. That is QC. But without QA, without this interim phase, you will find it a bit difficult to do QC. So QC is basically started to be based on individual engineers, individual person, and whoever comes, they have different standard, and that's very dangerous, you see. So if you plan beautifully, you want the material to be like this, like this, like this, you want the machine to be like this, like this, like this, you want the methods to be this way, you draw a nice flow chart, but inside there, you do not put in an alarm bell, you do not check. I mean, you do not plan to check. So you do not list down, basically, whatever that you are doing in QP is like you're looking into all these aspects, and this aspect will actually put into, it will actually have what are the level of desired quality. So you talk about, okay, I want this to be level 1, level 2, level 3, level 4. So from that desired level, you're creating that quality plan, which comprises of all the M's. And then underneath, you must have that testing, you see. So the part here, actually, when we talk about checklists, metrics, these are let me put it here. This testability and all these two are actually part and parcel of QA. So it is also in QP, you see. QP needs to list down how to do this thing. How are the marking system like? It's just like you guys asking me for rubrics, like sort of thing. Give us rubrics so that we know what we can write. Same thing, So you need to plan your rubrics first. You need to plan your checklist first. You need to plan how many times you want to collect data. You need to plan how many times you want to collect samples. You need to plan how many times you need to do the testing. How many test kits you need to use. How many sample, how many slump tests, how many static log tests that you need to do at which location, how many ball log that you need to take, for example, and what are the standards or what are the levels that are required, you see. So personal defined quality assurance as a collective term of formal activity and managerial process that are planned, and undertaken in order to ensure the product and services are delivered at a required quality level. So meaning that this component, one component, say, is completing. This component, what are the activities, what are the material, what are the things that you're going to be using, machineries, these are all in QP, correct now, like what we've mentioned in PQP. So then with that flow chart of how to do the work of this flow of work to construct this particular beam, you also put in the processes undertaken to ensure that it will be delivered, meaning that the testing at certain level, you see. So it is an effort, it's an effort to make sure that the processes loop are closed in that sense, So you have these processes of constructing, but make sure that you have doors that are closed, so that if there's a problem, the thing will start knocking, like there's an alarm that is going on, that this is not right. And then what do you do next, So, and then the actual carrying out of the of the testing, review, checklist, and actually QA is up to collecting this data. QC is the one that will look at this data and create into useful information and find out where are the problems and look into what are the solutions and how are the improvement made. So QP is like a baseline. QA is building on top. It's closing that loop of how to check, plan to check, and how to check and collect data. So audit is part of, you can see that audit is when I put down here, I think audit is part of QP. I mean, it's part of the QA, sorry. Yeah, so yeah, include quality audits, you see. So quality system assurance systems will include, objectives. It include establishing of the maintenance performance, the measurement, and including audit. So this tool is very important. And you need to plan to collect. So how many cycles, and all that, and how many improvement that needs to be done, how many checking that needs to be done, identify. I mean, these are very common things that you don't really need to. I mean, like it is part of it, so it's putting it very, very academically in that sense. But the actually doing it is things like this plan to collect data, how to collect data, how many times to collect data, what data to collect, and establishing the measurement, the metrics itself. Okay, so we also there are other things that also like other organizations that talks about what should be in a QA program. So you see, establish a level for major components, establish quality assurance, what are applicable to the subcontractors, to the suppliers, reporting and evaluating the procedures, what are reviewing the non-conformance, review the defect rectification procedures, So these are, again, the simple word is plan to check. I'm not sure whether this is confusing for everyone listening to this, because pretty much this is part of the PQP, part of the manual, okay? And you just imagine the manual is based on creating a baseline, and that baseline can be a flow chart, like technique of flow chart that takes benchmarking into consideration, design of experiment, all these things are part of the best baselines, and these baselines have the M's, and then they have the M's requirement, the M standards, and then after that we have planning to check, like how to check, what data to collect, how many times to collect, and what numbers to collect, and then after that, when you collect those data, you finish your QA. So you are actually doing audits in that sense. And then it's when you reach QC, is the part that you are looking at checking. You see, that you're comparing the actual with the requirement. So you have the collection of data. So you slump test how many times that you take. So you look at the numbers and then you see how many times that it fails, And then from there, you will proceed on to look at the measure. I mean, look at how to improve and find out the root causes and all that. So these are QC. QC is actually easy to understand because this is part that we are doing it. We go and we see the data. Now I have this 100 data of slump tests that I've taken for over 2 months, or over 6 months. So from there, I find that there's a lot of rejects, and why there is a reject. So you need to go back and find out the root causes. And the quality control tool like cause and effect analysis, trend analysis, histogram, scatter diagram, process control charts. These are some of the good analysis that you can take to study the data. You study data, you might say, I want to solve problems, you see. It may not be so simple, I mean, yes, at fault when something is rejected on site, your flow chart up there tells you already in your PQP that if it's rejected, what do you do next? Yes, that is immediate correction. But you need to take all this data and convert them into useful information using fishbone diagram or cause-effect analysis, or what we call cause-effect analysis, trend analysis, histogram. You can see where the peaks were at a trough, All this will actually help you to understand where the problem is. Maybe that is not the right supplier for you. Maybe this is the ground condition that you didn't think of. Maybe this is caused by acidity in the water. It can be a lot of reasons. So you do not want to keep on having rectification work, you see. So when you go up there and do testing after your planning, you realize that, hey, how come the problem are repeated, you see? So you keep on, when you go through the flow chart, that emergency management, yes, you need to solve problem right then and there, but you need to look into further. You can see that in a fishbone diagram, we will generally use also the bigger bonds will be manpower, machineries, methods, you see. So we're going back to our baseline in PQP to understand where the problems come from. It doesn't come from anywhere but that few M's again, you see. So it is matching with one another. Okay, and that is QC for us. You need to make things better. You cannot keep on doing ad hoc emergency management. So the things that you collect the data, QC manager, you must use that data.